By the mid-1990s, Intel's Pentium had become the beating heart of the modern PC, a name so dominant it was practically a synonym for personal computing itself. But dominance breeds discontent, and a scrappy crowd of clone makers, AMD, Cyrix, and others, smelled opportunity in Intel's premium pricing. Millions of buyers didn't need the fastest chip on Earth. They needed something good enough to run Windows, check email, and crunch spreadsheets at a price that wouldn't hurt. Into that gap between excellence and affordability stepped a tiny, almost unknown challenger, the WinChip, a processor built not to win benchmarks, but to win wallets. That challenger came from Centaur Technology, a small design house founded in Austin, Texas, in 1995. Centaur was, in essence, a scrappy skunkworks operation, a lean team of engineers who prized clever, pragmatic design over sprawling bureaucracy. It operated under the wing of Integrated Device Technology, or IDT, a company better known for memory chips and specialized logic than for going toe-to-toe with Intel. Why would a niche semiconductor firm bankroll an x86 processor? Because the license to build compatible chips already existed in the industry, the tooling and talent were available, and the low end of the PC market was wide open. It was a calculated, if unglamorous, bet. Rather than chase Intel and AMD up the performance ladder, Centaur's engineers made a deliberate, almost contrarian choice. They designed a simple, in-order processor core with a relatively low transistor count, sacrificing the aggressive superscalar complexity that made Pentiums fast but expensive and power-hungry. This meant smaller die sizes, lower manufacturing costs, and chips that ran cool without exotic cooling. It was a bet that efficiency and affordability, not raw horsepower, would find a loyal audience among value PC builders and cost-conscious buyers. That philosophy became silicon in 1997 with the WinChip 6. It was an in-order design with integrated MMX support for multimedia instructions, and crucially, it was pin-compatible with existing Pentium motherboards, meaning it could slot into cheap, familiar systems without redesigning anything. The press response was cautiously curious rather than rapturous, intrigued by an underdog with modest ambitions. OEMs building budget PCs took notice, and the C6 found a home among value-oriented builders and hobbyists hunting for a bargain upgrade. In everyday use, the C6 earned a surprisingly solid reputation. Its integer performance per clock cycle was genuinely competitive, making word processing, spreadsheets, and general office tasks feel snappy. But its floating point unit was its Achilles heel, and as 3D games became the era's must-have showcase, the WinChip stumbled badly on the polygon-heavy workloads that Pentiums and Athlons handled with ease. The result was a chip with a split personality, an office workhorse that gamers were wise to avoid. Centaur pressed on with successors. The WinChip 2 arrived with an improved floating point unit and support for AMD's 3D Now multimedia instructions, a clear acknowledgement that gaming performance mattered more than the original design had assumed. Plans for a WinChip 3, and later designs sometimes referenced as the 4, aimed to keep pushing the architecture forward. But Intel and AMD were locked in a furious clock speed race, pushing past 300, then 400 MHz and beyond, and Centaur's small team simply couldn't match that pace of iteration. The historical record on some of these later unreleased or lightly documented variants is a bit hazy, with details sometimes conflicting between sources. By the late 1990s, the WinChip brand itself quietly faded. IDT sold its x86 business to VIA Technologies, a Taiwanese chipmaker hungry to build out its own processor lineup. Centaur's engineering team, and its underlying design philosophy, carried on under new ownership, feeding directly into chips like the VIA Cyrix 3 and the VIA C3. The scrappy, efficiency-first DNA of the original WinChip lived on, even as its name disappeared from retail boxes. The WinChip never troubled Intel's market share in any meaningful way, and it's easy to file it away as a footnote. But its legacy runs quieter and deeper than its sales figures suggest. The emphasis on low power and low cost over raw speed anticipated a niche that would matter enormously later, in embedded systems, thin clients, and ultra-cheap PCs where efficiency trumps benchmarks. It's a reminder that the 1990s chip wars weren't just Intel versus AMD. They were a genuine ecosystem of competing philosophies, and even the underdogs left fingerprints on the path forward.